So we'll go ahead and get started. First of all, I see a lot of friendly faces in the audience. Thank you so much, everybody, for supporting us. What we're going to talk through today is kind of Capital One's journey that a lot of people in the room have helped make real. So yeah. But anyway, I'm Jim. I'm a distinguished engineer. We're going to do our hiring pitch first, but our distinguished engineering program, we started it in 2015. It's a great program for me personally. Like, I was in a people leader track for quite some time, and when I came to Capital One, they had the DE program, and it's great. Like, it lets you still progress career-wise, and you get to work on tough tech problems. So if anybody's interested in that, please come see me after. Happy to give information on that. And then one of the best parts about data engineering, the distinguished engineering program is, like, if you have great partners to work with here, like Kajal, she's the delivery leader for my space that I kind of work on. So, want to tell us about yourself?
Yeah, absolutely. Thanks, Jim. So Jim has this amazing benefit of coming up with these simplified, beautiful architecture diagrams and implementation. And then my teams and I actually have to make it real and deliver on time, at low cost, and at scale. So hi, everybody. My name is Kajal Wood, and I lead the enterprise data platforms for Capital One, primarily focusing on data storage and consumption.
Perfect.
And like Jim said, by the end of this presentation, I am pretty sure you are going to be amazed at what we have done, and you're going to want to be part of this journey. And so we are going to be hiring, so please see us.
Let's see if this works here. Perfect. So I'm going to start kind of telling about Capital One's tech journey a little bit. So I'm sure everybody's heard about Capital One, seen all of our awesome commercials, and the company was founded in 1995, and when we started, we were on-prem, and we were all this stuff, and now we're fully in cloud. We're doing generative AI and all those type of things. So one of the key ways we got there was with this terminology we use internally called "you build it, you own it." So we did not take an approach where we have giant central teams and you try to get one team to build huge platforms that you have to go to them and create bottlenecks and all those things. We've really focused on enabling our users to build stuff, which I think is pretty unique from other places that I've worked. So we're going to talk through kind of that today, and then we're going to go into some deeper details with our kind of data platforms and how we're doing some of that stuff with Databricks and all those type of things. So you build it, you own it. You can think of it as enabling self-service, but I do think we take it to another level that you'll get to see. So, like I kind of said before, Capital One was founded in 1994. It is still founder-led to this day by Rich Fairbanks. He is super involved still, and it's incredible what he does for us. And when he founded it, he always talks about, he has a few different terms he uses, but one, he always says he founded the company on an information-based strategy. So even early, 1995, we were one of the first companies to do ML models with credit decisioning. So we were one of the initial people to do that in that space. And lately he's been saying, data is the air we breathe. So he's always been heavily focused on data as a CEO, and that's trickled down to all of the company. I mean, we have on our platforms very large amount of internal users, north of 10,000. So our data stuff is, it's internal facing, but it is very, very critical. And we are starting to get a lot more stuff customer facing and getting it there pretty quick, which Kajal's going to talk about in some of her things. But yeah, so that's kind of the journey that Capital One's been on. And I talked about kind of that tech transformation. These are some of the things that we've done, right? So we've gone, we adopted microservices, architecture, we moved to open source. I think everybody has heard about our very big movement to AWS. We've exited all of our data centers. We've stood up, a data lake platform in cloud, and then now we're kind of doing all this Gen AI stuff, and we've hired a really pretty serious set of leaders in the AI space that I'm sure you've heard people like Prem talk before. But the one key thing in this that was remarkable is that cloud journey. I mean, we did it in 4 years. So, I mean, for a bank of our size to do that in 4 years is not an easy task, and it's not like we just did some of it and we left pieces there. Like we're out completely. Like we do not have on-premise data centers, and that, you know, we did that by, I mean, we have about 12,000 engineers at the firm. We got there by enabling those engineers to build stuff. We didn't like, you know, sit there and come up with the perfect architecture and say, hey, everybody's gonna build stuff like this. You know, we really enabled them to, you know, use AWS, use serverless technologies, and do all this stuff and build so we could move fast enough to get out of cloud. I mean, if we had tried to debate to build stuff the same way, I mean, we are a consensus-driven culture. We definitely wouldn't be out of cloud right now. So, so yeah, so that's kind of the journey that we've been on. And I'm gonna pass it off to Kajal now to talk through some other stuff.
Yeah, awesome, thanks, Jim. So particularly I'd like to share over here is AI has really helped Capital One unlock and understand our customer and its behaviors. And most importantly, look out for their financial well-being and deliver the holy grail of personalized, tailored experiences. This is something you're going to continue to hear from us as a constant theme. We really believe that our data has powered real-time experiences, and we do that in our business today. Like for our credit and debit card, we really leverage ML to be able to do credit decisioning. For our auto navigator business, we use it for inventory prediction as well as pricing. For our customer who logs into our mobile app, we deliver personalized offers and content. And last but not the least, a favorite for many of you who are premium members, for our premium cards, we are able to provide concierge solutions through our premium experiences. All of this is really only possible, and the success of AI and its acceleration is really only possible with 3 key constructs. The first being find and use the right tech stack. Spend enough time, as Jim said, on identifying that tech stack strategy. Second thing, hire the right talent. So very important. And I cannot emphasize enough on the quality and data governance and how important all of these 3 constructs are to be a really well-powered AI company. And we've really benefited from many of this across many of our businesses. So we'll talk, is that next one? All right, there are 2 key constructs, again, as we embarked on our data transformation journey that we quickly realized over the years. One was we needed to make sure that we empower our engineering talent that is truly working closely to meet the business demands. And we needed to do it in a way that they could be self-serviced. And to do this in a way that they could be self-serviced, we needed to make sure we were also solving for the problems in a standard unified form, which means we did not want anomalies, we did not want arbitrary uniqueness. And in order to do that, we had to build the cornerstone of governance and make sure all of our data was well governed, adhered to Capital One policies of data management, governance, and the commitments that we make to our regulators in a highly regulated environment. And the second thing was unified self-service experience. The combination of these 2 has truly empowered our business users and our tech teams who support these business users to be able to focus purely on delivering their business outcomes and not so much worry about the governance or all of that, because all of that is baked, those guardrails are baked in-house within the product and the solution that we deliver. So we'll talk a little more. Jim is going to take us through a little more detail and double click here. But again, our singular focus has been this unified self-service experience. And this self-service experience has several key components that are several producers of our data, consumers of our data, our risk partners, very important partners in our journey here, and our business users. They have the ability to interact with these components. We've also built a suite of runtime orchestration capabilities to publish data, whether it's through frameworks or tools, frameworks and tools for data consumers, not to mention infrastructure management and governance. All of these are fundamental for our ability for our engineers and our business partners to not think twice and continue to explore and advance our agenda. So Jim's going to take us through a little more detail on that.
Perfect. Thank you, Kajal. So the two big pieces on that previous slide was the design, what we call self-service portal, and sometimes we call it design time, and then we have runtime components. So in the self-service portal, there's the user interface and experience, data modeling, metadata catalog. There's deployments, and there's access approvals all that fall under there that you can think about that happening. We have tailored experiences for engineers versus a data analyst that wants to make a data set and all those type of things. So that's happening with a human being in front of it. And then at runtime, we have a whole bunch of stuff there that, we've heard a lot of the stuff at this conference about Unity catalog and stuff like that. Capital One's been building some of that ourselves internally for quite some time, but we have made it so that we can manage and understand what all of those pipelines are doing with a whole bunch of different tech that our different LOB partners want to use, all in at the same time. So, and we also have stuff like tokenization that we use. So all of our data that comes into the lake that we make available for our data scientists, it's, they're pressing a button in that portal to say, hey, I want this field tokenized, and it's tokenized for them. So we've been able to make a really good, simple way for us to get data available in the lake and from our, very diverse set of microservices that, again, fully on cloud and cloud native stuff. So the other big part of this too is we're able to be very, very real time with this. We have the majority of our data coming, in less than 5 or 10 minutes for our internal systems. So we've made a lot of progress there. So we're going to double click into a few of these and talk through some details now. So one, for the life of our data producers, this is what they're kind of looking at. One, they start with the portal, and up front, before you make any data at Capital One, you register your data set. So this is a pretty big advantage for us in the sense that we've seen a lot of stuff here around, catalog unification and all that stuff. That's not actually a huge problem for us because we don't let our users go into different platforms and make Snowflake tables or Glue tables or Unity catalog tables. We force them to make it in an external place that we then handle propagating that everywhere. So the steps here is one, they register it, they categorize it. It will go stick the tables wherever they need to go. We then do have users classify it. So if I'm in certain LOBs or certain types of data, they'll classify it and it'll get routed to the right person that we say is the data guardian for that for approvals. They then pick, their pipeline structures and how they want to do that. And then, they really do just hit a button, and it does go through more approval processes to make sure owners of those pipelines know what they're signing up for, because they're ultimately, when it breaks, they're responsible for it. But it makes it all very, very simple for folks to go through this and just get things to production in a standardized way. Now, we do have different patterns throughout this whole process, which Kajal will talk through in a lot of detail, that support different types of use cases. But the flow for everything is pretty much the same, whether we want to do low latency Dynamo databases, data warehousing, data lake tables, and thankfully that's all merging now, so we don't have to have both those experiences anymore. But that's kind of how it is at a kind of a high level. So if we take one step deeper, this is kind of the architecture that we take to handle the runtime piece and the design and the pipelines after they get deployed to production. So we have I'll just call it a control plane for us. We have an internal control plane that we maintain centrally. That's something one of our central platform teams builds. We aren't building pipelines in enterprise data. We're building these supporting services. So our central control plane will enforce and make sure, hey, this person registered this data set with this format and it wanted these rules. Now, when they coded that pipeline, are they following it, right? So we have all of that ingrained in there. We do capture lineage from lots of different tools. We like I said at the beginning, we've got 10,000 plus users. I would love for everybody to pick one tool, but it's not always a fun debate with everybody, so we've got to support a lot. And yeah, and then again, this is all automatically deployed. So I'm going to pass it off to Kajal next or no, sorry, I got one more slide. So when we do these deployments, we started off on a journey with very central platforms. So we had, a giant Kafka cluster. We tried to follow a Kappa architecture. And that was cool, it was great. It worked really well for CDC-based ingestion to our lake and getting data into the lake in real time. But we saw very quickly that, that we needed support for other stuff, like for data engineering workloads that wanted to use Spark and do more batch-like transformations or even micro-batch transformations, stuff like that. And they didn't like the central pipeline we built. So we actually started noticing a lot of weird anti-patterns across the environment to avoid kind of our governance a little bit and only kind of stick it through the pipeline at the end. So we realized very quickly that, okay, that one pipeline we built is great and it's centrally managed, and we've onboarded probably 2,000 or 3,000 ingestion pipelines on that, but we saw very clearly we needed another type of model where teams wanted to locally own their code, they wanted to locally own their build, and they wanted to use different tools. And kind of like we said in the beginning of all of this, like you cannot move fast if you sit there and try to, completely dictate everything. Like you have to standardize a little bit, but at the same time, you have to free people up to do what they want to do. So we did come up with another part of our convergence strategy to our platforms that was a locally managed SDK-based implementation of all the controls that has been very popular with engineers. So now we kind of have a few different models there that we've seen successful, and now even with all this Gen AI stuff and where data is getting closer to the edge and everything, we're only seeing more and more of that. Like you have to get governance everywhere, and unless you figure out how to stick it into locally managed places, like it's going to be pretty tough for you to have the full visibility of your environment. So that's what we talk about with centrally managed versus locally managed here. And then now Kajal's going to talk through some key examples that show each of those, and with actual kind of products that we build and deploy as a enterprise data team at Capital One.
Thanks, Jim. So we have 4 different flavors of data applications that our users typically deploy to our platforms. The first one is primarily for our software engineers. So what are our software engineers doing? They're really building business applications to support business outcomes. And they're doing this by building these applications in a way that produce data, the microservices produce this data. And what we are asking these users is to preferably in real time publish data to a centrally managed streaming ingestion platform. And we'll talk more about this particular platform, but that's one of the key capabilities for our software engineers. So now we've taken the hassle out of thinking about data infrastructure and the governance and all of that. All they have to focus on is building the business application and the microservices that power those business applications. Then the next set is really our data engineers. Now we have several pipelines and teams that do very data intensive publication. For those, we kind of built a locally managed solution, and we packaged this locally managed solution with several automations in place, particularly for our governance, our policies, staying well managed, and all of that. And that has really, as Jim said, really well received. The third group of users is really a data analysts and data scientists. Today, as part of our software for our machine learning development lifecycle, you're going to see a lot of rapid prototyping and iteration. And as part of that rapid prototyping and iteration, these users need to store several artifacts. And so we'll talk more about how we evolved our solutions, some of the problems we saw, and then where we are today from an adoption perspective. And last but not the least is our ML engineers. Now that we have published some of our data during iterations for rapid prototyping, we actually need to operationalize this in production. And we need to operationalize it in a way that it can be accessible in a low latent fashion. And so this is the group of users that are going to access those features that were built as part of rapid prototyping and deliver them in low latent fashion. So these are like typically the 4 sort of groups of users that we've seen and the type of applications these users deploy to our platforms. So we'll start with the first one. So in our journey of building the first pipeline, like I said, we started with a streaming platform. Now this pipeline was very well received. We were ingesting massive amounts of data, terabytes of data. It brought in 2 key benefits. The first benefit was, again, our business users were able to just stream data here. They did not have to think about any data infrastructure or any type of other automations related to data. They were purely focused on this. And this data we were able to enable this data in the lake. The second thing primarily was the scale. Nobody had to, again, worry about infrastructure management, all of that, because our streaming platform was able to do that. If some of you had an opportunity yesterday to attend one of our colleagues' presentation, this was primarily focused on data ingestion pipelines. So once this data landed in our streaming platform, we now have the ability to use Delta format, and you all heard a lot about that today in the presentation in the keynote, to really allow to ingest this data in the lake. And now we have been able to drive massive amount of cost reduction by building that ingestion capability. And we were able to bring the cost down by about 85% as part of moving to the Delta platform using the Databricks capability of Delta ingestion. And we are also getting ready to leverage Delta Uniform. So very exciting times. Now our data is in the lake. Our application teams have not had to worry about managing the infrastructure. It was almost like a fire and forget, right? And they got all of the data governance and the automation associated with registration of your metadata and all of that. So this was really good for software engineers. But our data engineers, they're a whole nother breed, right? They were enthused about it, but not super enthused about it, I'd say. Primarily because there was a lot of intensive computation that they needed to do. And this type of intensive computation, really what they needed was the flexibility to build their own pipelines, the flexibility to publish and build their own transforms. And so in order to do that, our teams built libraries and SDKs and packaged all of the wonderful things that we build in a central platform for governance and data management standards. So now, out of the box, you have lineage, you have metadata registration, you have the ability to publish at speed based on your platform. And all of a sudden, we packaged all of this. And now our data engineers with heavy, intensive compute are able to do this with their central pipelines, with their local pipelines. So that was primarily a big shift. Jim was a big change agent in enabling that because we saw a lot that as the team started to publish on the central pipelines, that there was a need for that, and that was massive amount of effort and realignment, and largely like a big cultural change too, to think about and shift left your governance and automation and all of that, and bring that, really empower our users, our business users to do this, right?
There's one other huge benefit out of this that we've been able to do. Like we're able to move to Iceberg and like take advantage of stuff like that with Snowflake. These users didn't have to do much, right? Like we're able to, handle upgrades behind the scenes for them, push SDK updates to get them on latest versions of Spark and all those things. And, we're actually in the middle of a very nice Iceberg move that's gonna, be super, super beneficial to Capital One without having to, again, we have 12,000 engineers. We would not be able to move like that if we had everybody doing their own thing, but we still enable them to do what they want. So it's an interesting.
Again, like striking the right balance between being central, being local, empowering our teams, at the same time standardization, right? These were like two very different types of use cases for two very different types of business users. The third one, this is one of the more recent ones that we've really normalized around. So again, thinking back, when we started our journey on building this sandbox type environment, we had a lines of businesses stand up their own local sandboxes and do rapid prototyping and iteration for their model development and lifecycle. Now, all of this meant each line of business had their own like retention policies, their own governance, and all of this data in a highly regulated environment needed to be used for a model risk office to be able to approve a model when it went into a final production stage. And so this meant like longer retention and all of that. These policies needed to be standardized across all of our lines of businesses. So we again here came up with two key capabilities. One, a standard storage location, which is our S3 bucket, where users could store all of their model exhaust, their training data if needed, and all of the evidence, whether it was output, model output, and all of the analysis that a lot of teams use Databricks to do in this sandbox. We also enabled a self-service capability for these users to be able to go and provision their location. So whether it could be a personal location for their own iteration and prototyping, or it could be a team collab space where the entire team of engineers and scientists could collaborate on a model. So the combination of this was part of our, again, self-service portal. Jim talked about like a basic unified experience, and we are just continuing to build on that unified experience, right? The things that we did as part of this particularly were we integrated our authorization service so that the right users had access to read and write to these team spaces or collab spaces as well as individual, right? We also enabled our central capabilities for scan, whether you're scanning for like malware or highly sensitive data. All of that was, again, part of this exercise. A data scientist did not have to think about that. It's all part of the platform itself, right? And at the end of the day, now we have about, I'd say like more than 500 users already in our lines of businesses. We have about more than 10 petabytes of data that's in this storage location. And we have a really solid handle on our governance and controls. And we continue to identify great policies that will help us stay true to enabling the right deployments in production and be really solid from a risk posture. So now that we've talked about like mostly the build and train and the rapid iteration and prototyping and all of that, last is one of our other applications, which is called the low latency data store. Now there are two flavors of this, or two types of users that typically care about this. One is as you saw, our the ML engineers and our data scientists. Once they build these features, and they build these features in a build and train model, now we need to productionize these use cases, which means these features need to be available in real time in a very low latent fashion. And so our low latency data store will allow to onboard these features so that at compute time, at model time, runtime, you're able to look at and retrieve these features in low latent fashion. There are also several different flavors. You could have like real time, absolute real time, and then we also have an ingestion pipeline for batch type features that in some cases you only need to compute something maybe once a month, once in an accounting cycle or something like that. The other type of flavor here is outside of ML is really like think about supporting your customer 360 view. You have an agent, there's a call center agent, someone calls in, the call center agent wants to look at a 360 view of the customer and what the customer is doing. So we have several different business applications that power that, and you want to listen to streams from all of these different business applications. So this particular ingestion capability and data store allows you to combine those multiple streams in a fit-for-purpose operational data store on the fly. And then you're able to retrieve this in a low-latent fashion. And so we've had like tremendous success with this, as Jim said. Right now we are using DynamoDB, and we have plans to be Polyglot and expand to many other data stores. And so that's primarily our last use case that I'll be talking through today. So you've heard a lot about several of these things today. I'd say Capital One is a data company. You heard that, which means our data platforms have to deliver at scale, at cost, right? And in order to do that, these are the three key pivotal things that have really allowed us to succeed. One is to enable the unified layer self-service experience, empower our users to do what they need to do and not depend on central teams. The second team is build experiences that are tailored to different types of use cases. Going back to our slide on software engineers, data engineers, ML engineers, and data scientists and data analysts. We have different experiences for all of them. And then last but not the least is automate everything from our runtime to our design time. You heard about metadata registration, you heard about governance and controls, all of that. So those I would say are the three key takeaways from my experience. Right? Thank you, everyone.